Hi guys, welcome back to my channel. Thanks for such good response on my previous videos. Keep supporting my channel. Don't forget to like, share and subscribe to my channel. So I am doing videos for my college purpose. Your likes will determine my marks. So don't forget to like this video. Do support my channel.
So today's topic is on discuss algorithm. Without any further delay, let's get into today's topic. So introduction to discuss algorithm. Discuss algorithm is a popular algorithm used for finding the shortest path in the graph. It was conceived by Dutch computer scientist Dijkstra in 1956. The algorithm is widely used in network routing and geographical mapping applications. The key concepts to remember while solving a discrete algorithm is that it operates on a weighted graph where edges have non-negative weights. The algorithm maintains a set of nodes whose shortest distance from source is known. It is important for the graph to be connected, otherwise some nodes may remain unreachable, and it is important for the graph to be directed to. So here is an discuss algorithm for single source shortest path, where the input is the weighted connected graph G, the vertex comma H with non-negative weight and its vertex source S. The output will be the length of distance of the shortest path from source to the vertex. Now, if we go through the algorithm, we see that we initialize with q, where the initial we initialize with the priority q to the empty for vertex v in P, that is dv is infinity, pv is equal to null. Then we initialize the vertex priority in the priority q, we insert q comma v comma dv. Then we update the priority of s and ds as 0. Then for I is equal to 0 to v minus 1, we delete the minimum priority element. Then we continue if du star will be du and pu star will be pu. If we go through the sum, we'll understand better. So let us consider this graph where that it is a directed weighted graph with nodes a comma b comma c and source node as s. The weights, source to vertex a is 1, source to vertex b is 3, a to b is 1 and a to c is 10, b to c is 4. So let us see how will we find the shortest path of this weighted graph using this class algorithm. So the first thing we have to keep in mind is we have to make a column with explored and unexplored nodes. First is the unexplored node. So all the nodes in the graph are unexplored, that is source, the vertex A, vertex B and vertex C all are unexplored. In the second step, we put the explored node as an SOS. SOS is that S is the explored node. From S, what are the nodes we can explore is A and B, whereas C remains infinity because there is no edge connecting directly from source. So source to A is 1s, source to B is 3s because we're visiting the B and A vertex from 1 and 3 weights. Next we considered A as the explored node with S, so we can visit B and C through A from S. So from S, A 1s, we can visit B as 1 plus 1 2A. So it is from A, so we have to take it as 2A. And we can visit C through 1 plus 10, that is 11. 1 plus 10, it is 11. So source from A, then C, that is 11 plus 10 plus 11, 11, so it's 11A. Then we come to here, source, we take source, we take the A vertex and B vertex both. Then when we take the B vertex also, we can visit the C vertex. The only vertex that is not unvisited is the C. So the C vertex can be visited in a more minimum shortest path, that is 3 plus 4 is 6. So we can it's at 7. We can visit it at 1 plus 2 plus here from here it is 1 plus 1, that is 2, 2 plus 4 is 6. So we can visit it as 6b, that is from A, then B and C. So we can visit from source, then A, then B. So all the nodes are here used to visit B, so it is 6b. Then we take C to also the explored column, and from 6c, from C there's no left unvisited or unexplored vertex. So here the Dijkstra's algorithm ends, and this is the final, the output we get is SO0, comma A1S, comma B2A, comma C3 6B. So let us go into the next slide. Here we actually get a matrix where through the graph we have considered in the previous slides, where source to source is 0, source to A is 1, source to B is 3, and source to C is infinity. Then again A to S is infinity, A to A is 0, A to B is 1 and A to C is 10. Then B to S is infinity because there's no edge between A to B because it's a directed graph. There's no edge going from B to S, so it is considered infinity. Again, from B to A, there's no edge directed towards A from B, so it is again infinity. And B to B is 0, B to C is 4, we have 4, and C to C, C to S is infinity, C to A is also infinity because there's no edge directed towards A from C, and C to B is also in infinity, C to C is 0. Then we get this output graph from the previous from the previous output we got, that is S0 S A 1S comma B 2A and C 6B. So from this output, now we will be drawing this graph, that is S to A is 1S. Here is 1S, so we connect 1S. B is 2A. From A to B, we have to connect through from S, A to B have to connect. That is 1 plus 1, 2A. 6B, 1 plus 1 plus 4 is 6. So this is the final graph we get as the output. So this is how we get a shortest path graph from A to B to C from the source to using a Dijkstra algorithm. So let us learn more about Dijkstra algorithm in the further slides. Um, so iterative process. A Dijkstra algorithm is an iterative process that is repeatedly selecting the node with the smallest distance. For each selected node, the algorithm updates the distance to its neighboring nodes. This process continues until all nodes have been processed or in the queue is empty. We have done it already. Next is the complexity. The time complexity of the Dijkstra algorithm can be based on the implementation. By using a simple array, the time complexity is O v power 2, where v is the number of vertices. So it is O v power 2. Then with the priority queue implementation and binary heap, the complexity can improve to O v plus e log v. This can also be the time complexity. Usually we considered O v power 2. The next is the use case, that is the applications of Dijkstra. Dijkstra algorithm is commonly used in GPS navigation systems to find optimal routes. It is also applied in network routing protocols to determine the best paths of the data transmission. Additionally, the algorithm is used in various applications in artificial intelligence of path finding. Now, limitations. There are few limitations of the Dijkstra algorithm too. That does not work with graphs are they contain negative weightages, will not be used for Dijkstra algorithm. In the case with negative weights, the Bellman-Ford algorithm is more appropriate choice. The algorithm may also be less efficient on very graphs without proper data structure. Now, if we consider the conclusion, that is all what we have studied in the previous slides, that Dijkstra algorithm remains a foundational method in a graph theory and computational science. Its efficiency and versatility makes it a virtual tool for solving shortest path problems. Understanding the algorithm enhances one's problem-solving skills in various computation contexts. Feel free to customize any. Let us go. Thank you for seeing my video. Please do like and share this video.